This is the second in my video series on how to use Google Sheets to do inferential statistics in a more intuitive way using simulations. In video 1, we took this Pulse of the Nation survey conducted by the folks at Cards Against Humanity back in 2017 and 2018. We took their February survey. We took the 2 questions they asked of whether or not people approve or disapprove of Donald Trump and how many times they think he's been married. We cut and pasted them over into this new sheet, and then we very carefully scrubbed the data to clean out all the nonsensical responses and the people who neither approve nor disapprove. Now we're going to ask the question, who thinks Donald Trump has been married more on average? People who approve of him or people who disapprove of him, and whether or not that difference is what's called statistically significant, meaning it cannot be attributed to random variation in the data. So to find the average of the people who approve of him, the people who approve of him, their number of times they think he's been married, start in box B2 and go down to box B239. We're just going to type equals average, open parentheses, B2 colon B239, close parentheses, enter. Now, so people who approve of Donald Trump think he's been married on average 2.68 times. People who disapprove, if the approves end at 239, these must start at 240, equals average, open parentheses, B240 colon B. I could really say whatever because it'll go to the end of the sheet, but just for best practices, let's figure out where the sheet ends. And it's at 574. B574, close parentheses. People who disapprove think he's been married on average of 2.91 times, which is closer to the correct answer of 3. For a difference of, this will be cell E3 minus cell E4, equals E3 minus E4. Enter. Difference of 0.22. I'm going to retype that number here so I don't forget what it is and it won't change. 22435. I don't really care about the negative. I'm not concerned with which one is higher. I'm just concerned with how big the difference is and whether I can generate a difference at least that big by randomization. Now, before I do anything else, the next thing I'm going to do is start changing this column. Before I do anything else, I am going to duplicate this sheet so that as I change things, I don't mess with my original sheet. Now, I'm going to essentially test the null hypothesis. The null hypothesis is that people's estimation of the number of times Donald Trump has been married has nothing to do with his approval. It's just random variation. That's the null hypothesis. If that is true, can you generate a difference this big, 0.22, just by randomly assigning the number of times people think that he's been married to the people who approve or disapprove? Google Sheets lets us do exactly that. We can randomize this column, randomly assign the number of marriages to the approval or disapproval, and see what happens to our averages. Click on this little arrow next to column B, scroll down to randomize range, and this is our first trial. And no, we generated a difference much smaller than the one we observed. I would call that trial a failure. We failed to generate a difference as big as the one observed using randomization. Trial number 1 was a failure. Let's do it again. Trial number 2, another failure, but closer. Trial number 3, another failure. Trial number 4, another failure. Trial number 5, another failure. If I were doing this as part of my project, I would do a full 100 trials and I would count the number of times that this number is equal to or larger than this number, ignoring the negative. If that happens at least 5 times out of 100, that means even if there was no connection between the approval of Donald Trump and the number of times people think he's been married, we would still be able to we still have at least a 5% chance of generating a difference at least as big as the one we observed. So we cannot say that the difference we observed is due to any real effect of approval or disapproval on the number of times people think he's been married. On the other hand, if we have less than 5 successes out of 100 trials, then we can say there is a less than 5% chance this difference could be due to randomness, which means we can say that it probably is statistically significant, meaning no, really, whether or not you approve of Donald Trump does impact the number of times you think he's been married.